Hey, what's up? It's your old pal, Mr. Cook. And let's see, we're going through this review, part one of the parameters, right? Like parametric equations. Which ones do we want to do? Let's see here. I guess, yeah, I'll just make a real short video going over just these couple problems right here, just converting. There's like a ton of different ways where you can convert from rectangular form uh, into parametric and vice versa. So I'm just going to show you, in my opinion, like the easiest way to do it. And then you can sketch the curve. And when you sketch the curve, use your calculator, but always make sure that you include directional arrows for it. So it's like map out like where it's going, basically. Okay, so converting the equation to rectangular form. This is really easy. All you got to do is this. Notice that you have a t here and a t here. Just solve for t in one case and then substitute it into the other equation. Which equation, the x equation or the y equation, would be easier to solve for t? I bet you already can guess, right? It's that first one, the x equation. So if I solve for t in this case, t is going to be equal to x over 2. And sure enough, you can just plug that right in for the t here and get it in rectangular form. So y is equal to t, which is x over 2 squared plus 3. There you go, rectangular form. It's just in terms of x and y, so you're all done. Then we want to graph this thing out, so just use your calculator. So then on your calculator, we're gonna, first off, mine is in rectangular form, so I got to make sure that I turn it into, I put it into parametric form. So I hit mode, and then parametric mode. Now I can graph it out real easily. Excuse me, gosh. Okay, so x is going to be 2t, so 2t. And then y is going to be t squared plus 3. I graph it out, and it looks like that. And yeah, if I were to graph out, like, it looks to me like that's supposed to be a parabola. So if I use negative t as well, like maybe I'll use like negative 10 or something like that, it'll graph it out a little bit further. Yeah, it looks like it's just gonna be a parabola. So all I would do is this. I would like graph the parabola like that, and then, oh gosh, I shouldn't write that arrow there. Did you guys notice the direction that it's graphing? If you didn't, that's okay. Just graph it one more time. So like, just change the 2 to a 2. Just write 2 one more time and then enter. And then it'll graph it again. Now pay close attention to the direction that it's graphing, okay? Notice that it goes from left to right. So the arrows are going to go from left to right like that, okay? And that's all you got to do. And this is for like, I guess it's also helpful to write it out for t greater than or equal to 2 and then less than or equal to, what do we have for the window? 6, so 6.28. Let's just say it's 2 pi. And, that's good enough. That's like how the graph looks basically. I don't know. Would I need like one other point? I'm trying to think about like how much detail I'd want. I don't want a lot, but it looks like it goes through 0, 3. So like, I just like say, hey, that's 3, I guess, or something. That's my graph. 10. So if we have, trigonometric functions, there are different rules that you can use to solve this. However, you can just stick to the same old path that I went over here. Just solve for t and then plug it in. Now, neither of these are particularly easy, but you can still solve for t. Like if I just started with x, if I want to solve for t, then if x is equal to 3 times the cosine of t, what I would do to make this really easy on myself is just get t by itself. So I'd divide both sides by 3, and then I'd undo the cosine part, right? So how do I undo cosine? I do cosine inverse. So cosine inverse of x over 3. And that's equal to t. Well, guess what? I just solved for t, and t is exactly that value. So I can, solve for y in terms of x, right? By just substituting that value. And so 5 times the sine of t, and t is going to be cosine inverse of x over 3. And yeah, there's like some domain restrictions here and stuff like that, but it's in rectangular form. That's all I care about. And that's, all you should care about too. Here's your answer. Okay, and then if I want to graph it out, again, I just go back over to my calculator and graph the thing out. So let's see here. 3 times the cosine of t. And then I got 5 times the sine of t. And if I graph it, it looks like that. It's like, I don't know, it looks like a circle to me. No, an ellipse, because it looks like it's going up and down by 5 and then to the right and the left by 3. It looks like it's centered at 0. So 0, 0, and then I go to the left and the right by 3, up and down by 5. And then did you pay attention to the direction that it's going? I kind of forgot, to be honest with you. So you know what I'm going to do? I'm just going to graph it one more time. And here's the easy way to do it again. All you got to do is just press, see how it's 3 cosine t? I'm just going to type 3 again and then enter and then graph it. Now you can see the direction that it's going. It looks like it's going counterclockwise. There you go. That's all I would need. All right, for number 11, same thing. Let's see. Let's get theta by itself. Maybe this would be the easiest one to solve for. I don't know. So x equals 2 minus 3 times the cosine of theta. So let's see. I'd subtract 2 from both sides. So x minus 2 equals negative 3 cosine of theta. Then I divide both sides by negative 3. So that would get me x minus 2 over negative 3 is equal to cosine of theta. And then I'd do the inverse cosine on both sides. So cosine inverse of x minus 2 over negative 3, and that's equal to theta. Okay, and then for my rectangular coordinates, I would just plug in theta for that value. So that's going to go in place of theta. So negative 3 plus 3 times the sine of, and then all that stuff, cosine inverse of x minus 2 over negative 3. There you go. There's my equation in rectangular form. All right, now to graph it out, I'd use my calculator. So we have 2 minus 3 times the cosine of theta, or t. And then the next one is negative 3 plus 3 times the sine of input value, t, let's say. And graph it out. I don't know, it kind of looks like an ellipse to me again, right? So here's how you can map out like exactly where it is, which is pretty neat. So the y value, the x value and the y value here are going to tell you the center of the ellipse. So we're going to go to the right by 2, and then down by 3. Here's the center. And then these values are going to tell you the radii for each of them. So negative 3 cosine, so that's going to be the 3 in the x direction. So go to the right 3, down, and then to the left 3, 1, 2, 3. So like right there. And then the 3 here is going to tell you, I guess it's a circle, so it's going to go up and down by 3 as well. So 1, 2, 3, and down by 3, 1, 2, 3. And then graph it out. And then we just got to tell where the orientation of it is. Is it clockwise? Is it counterclockwise? Let's take a look. So I didn't pay attention again, but it's okay. I can just see real quick. All right, looks like it's going clockwise this time. So that way. All right, there we go. So there's our graph. So yeah, I just thought I'd do those couple problems, however many it was, 3 problems or whatever. 3 problems real quick. That's the end of this video, and then we'll pick up on the next one in a bit. Okay, hope you found it helpful. Just go get some help if you didn't find it helpful. I'll always be available before school or after school. As long as I'm at school, I'm there to help. Okay, thank you very much. Hope to see you in the next video. Bye-bye.